We have still 5 minutes, right?
Yes, ma'am. Can we start the session, ma'am?
Yes.
Good morning to everyone present here, and welcome to the day two session on IoT simulation. The session is yours, ma'am. You can now continue with your lecture.
Thank you. Yesterday we were discussing about say the basics of Internet of Things. What are the hardware we need, software we need, right? How the architecture looks like, and some of the applications and issues we discussed. Just to go through a quick revision on what we discussed. So here is a overall architecture or an insight on how the IoT system should look like. Okay, we have an hardware like sensors, we have actuators. So we know sensors sense the data and actuators perform the action, right? Based on the command sent, so it perform the action. And embedded system can be one of the device in an IoT. Okay, so embedded system is an subset of IoT that way. Okay, so then we need an network for data communication. So where mostly we are using an internet as a communication network. Okay, so basically we have to concentrate on four operations in IoT. So that is sense the data, analyze the data, and communicate and perform the action. So sense, analyze, communicate, and act. Okay, so these are the four main operations in IoT. So all the devices which you are connecting in an IoT network will be performing either of these four tasks. So coming to an IoT ecosystem, so this gives you a complete architecture of say how the IoT system, right? How the IoT system should look like, or what are the different components, and how the components are integrated, to work with each other. But one practical difficulty here is you cannot write a complete ecosystem of an IoT because it's such a huge platform, right? You cannot include all the components in the ecosystem. So the most important components are covered here. Say for example, we have a sensing devices. We need an embedded processing and the connectivity. Okay, so is one group of components which plays a role. So here, embedded processing is required to say sense the data like temperature, pressure, and to communicate these values to the connected devices through the connectivity, like say Wi-Fi, RFID, or GPS like communication you can use here to communicate between the embedded system and the connected device. And we have a smart devices. So here, smart devices, say we have a smart grid, smart light, we have a smartphones, energy, okay, smart energy system, and smart city, and so on. So there are smart devices which is connected to this IoT, and we need an environment which supports or interconnects all these devices. And because the smart devices, it requires more of data analysis, and bulk data we'll be dealing with here in some of the applications. So we need a cloud computing and big data concepts here. So IoT is not just one technology, not just one concept, as I was mentioning yesterday. Okay, it is a multidisciplinary concept, so you have to bring in lots of technologies and concepts here. So then we have a technology, software, and application here. So we use a different technologies, and we need a different algorithms to do a different task, right? Based on the application you have to choose. And the most so next is a technology stack. So see, the IoT system makes a decision. That's why you need a smart devices there, right? So whatever data sensors have sensed, that should be analyzed, and based on the analysis, the IoT system has to take certain decision about the action, right? So we need a decision framework here. So what are the components which is taking part in making a decision in IoT? So we have a device hardware, right? A decision can be taken at the hardware level, or an algorithms, you can use in algorithms to take a decision, right? Or you need to take a decision during the communication, right, where the data has to go. Okay, so how much data has to go. So this kind of the decision has to be taken by these applications. And we have in a technology stack. Okay, so we have a different components considered at each level. Now, for example, user experience, right? Now, here the user can interact with a device at every level of an IoT application, right? So we need to take an user requirements. We need to take the user say concerns. What who are the users? You will be in a different stages or levels of an IoT. Now, for example, who will be using an end device? Okay, so as per that user, you need to design the end devices. right? And who will be accessing to the software, right? The controlling software or data analysis software. As per the that user, you need to develop the device software, right? And who will be accessing to the communication? Who will be controlling the communication? Say a network administrator might be doing. You need to give a certain options and the permissions for the network administrator at the communication level, right? So at each stage, you have to consider the different users' requirement and experience when you are developing an IoT system. And then comes to the data decision area, right? In the data decision area, so at the device hardware level, you should know what data you have to sense, right? What data you have to capture. So and software, what you have to do with the data, right? So the software, because you use the software to analyze the data, right? Now you have captured the data. The next step is what you have to do with this data which you have captured, right? So that decision has to be taken by the software, data analysis software. And then comes, now you made the analysis where the result should go. Okay, to whom you have to send the result. So or the data. So this decision has to be taken at the communication level. And then do you have to save the data, or do you have to process it further? Okay, so then comes the cloud computing, right? So if you have a bulk amount of data and you need to do deeper and further analysis, then you can make use of the cloud platform for further analysis of that data, right? And then the business decision. So the business decision, see why, if you are using an IoT application for the business purpose or for financial purpose, okay, then you have to bring in the business logic in this particular thing, right? So say for example, if you take in a energy management system, right? For example, you have a power grid, smart grid, and smart power grid, right? So there comes in the financial potential in the IoT system. Now, for example, say there is a power cut, and the IoT system which you have developed should automatically reroute the power and make sure that there is a constant supply of the power, right? So this is one of the goal of power grid. And why are you doing this? Because we have something, a profit or a financial associated, the cost associated with that, right? So if you are giving a constant service to the customer, then customer will definitely provide a suitable cost for that, right? So in that case, you have to bring in the business logic into the IoT system, right? And then the technology decision area. Now, what is this technology decision area? Yesterday we discussed, we use a different technology, say at the communication level, at the cloud level, or at the device level. We will be using a different, kinds of technology, right? So you have to take a decision about in which particular layer, what technology you have to bring in, okay, into the application. Then comes the security area. Now, what security measures you are taking? Now, for example, if you have an hardware, so you may have to give us some passcode to say to switch on that particular hardware or to access that particular hardware, right? So, how much power you have to give to the hardware, right? So, all these safety measures, where to deploy the hardware, right? So way to safely deploy the hardware so that it is free from the theft and environmental implications, right? So if you take a software level, again you have to go for a different level of security. At the communication, you have to go for a different level of security. Okay, so these what kind of security you need to provide at different layer, you have to decide. And then comes the most important, that is standards and regulations, right? See, whatever the system you are developing, it should not be against to the say the regulations, because you are developing it for the public, right? The most of the IoT devices is used by the public, isn't it? So it should compliance with all the required quality standards and regulation. So again, you have to work on what standards I need to follow. Now, suppose if you're say using a routing algorithm, then what standard you have to follow in the communication? If you are using an Wi-Fi, then there is a specific standard to implement that Wi-Fi in your IoT, isn't it? If you are using a sensor, then you have to bring into what are the privacy standards you have to follow, right? So like this, at every level you have to look for standards and regulation, do's and don'ts, and when you are developing the application, right? So this is about the decision framework in IoT. See, all these things are homework you need to do before you start designing an IoT project, right? It's not like you randomly you just write a block diagram and start implementing it. You should not do that. So you should know in and out of the application or a project which you are developing, what are the pros and cons of that, what are the possible risks, who will be benefited from this IoT system. So all this homework you need to do, and whether the devices which I'm thinking to design is available or not. So sometimes what happens, we get an idea, but we end up in a situation that we can't implement it because some of the hardwares are not available, or some of the hardwares you are not permitted to use, right? So if you do a proper homework about these framework, what technology you need, okay, so then definitely you will end up with an efficient design of an efficient IoT system. Now, as we discussed, the main IoT components are, we have sensors, users, smart devices or standard devices, and we need a gateway for communicating the device, right? And then we need a cloud for higher level of computations. Okay, so with respect to these components, we have a four stages in an IoT solution. Means when you are designing an IoT system to solve a particular problem. Okay, so you have to take care in these four stages. So yesterday's one of the participant was asking about can you mention the research areas in IoT? So answer is this: you can do the research in all these four stages. Okay, so there are lots of open issues in these all these four stages. Now coming to the first stage, see, we have a pre-stage, that is a things. Now you have to find out why do I need IoT. Okay, you have a particular problem. Now, for example, say you have to design an intruder detection system for your home, right? So this is a problem statement. Now, the first thing you have to find out, should I go for an IoT for this? Okay, it has become, you know, the fashion that the moment you see any hardware or device, we immediately switch on to the IoT. It's not necessary. If you can solve the problem with a simple embedded system, go for that, right? So you implement IoT only when and where it is required. Okay, so this is where you need to do lots of homework before you coin any project, right? So now coming back to our intrusion detection system, now where you need an IoT system here. Okay, say for example, when you're not at home, when you're away from home, so if any intruder is coming to your home, then you need an alert, right? So obviously, when you're outside a home, you don't know the distance where you will be from the home. So you need a higher network to connect to your home network. Yes, this is one of the problem in a problem which can be solved using IoT, right? Now, another example, say you are in a home, you are in a room, and you have to control your main door, right? So in this case, do you need an IoT? Do you have to connect the devices to the internet? Not necessary. You can go for any shorter or NFC or any the shorter distance communication also here, right? So if you are away from the home, if you are in a say in a different place, then you require an IoT to solve that particular problem, right? So now the identify the thing which you want to make it to communicate. The whole concept of IoT is making a non-communicating device as a communicating device, right? So that's why that is what the robustness of IoT is. The devices which could not communicate so far, now using the technology, you are making such devices to communicate, right? Now in the intruder detection system, the door is a thing, right? So far the door was not communicating, right? Now, by embedding some sensors or some additional devices, you are making a door to talk to you, right? So identify the thing. This is the first step. And then what kind of sensors you need to embed. Okay, identify the sensors. It may be wide sensor or it may be wireless sensors, and you also have to identify the actuator. Right now, what sensor you need to know that there is an intruder. You can go for a proximity sensor. Right. So, what is proximity sensor? If some object or somebody is nearing to the sensor at a specific distance, it will create an alert. Right. So, if somebody is nearing to the door, okay, so then it can create an alert. Okay, so creating an alert, it may be an alarm or it may be sending an SMS or it may be, adding an additional lock to the door. So the action may be anything. So this action is performed by the actuators, right? Now identify what sensor you have to use in your project and what action you have to perform. As per that, you choose the actuators, right? And the second stage is internet gateways and data acquisition system. Right now, you have to remotely send the data, right, to the user. That's why you need an IoT. So here, what type of network you have to use to connect a user to the say sensor data or user to the actuator, or sometimes your sensor is in a different place and actuator is in a different place. Okay, so how to connect them, right? So if you take in a airport surveillance system, right, a proximity sensor will be placed near the door, and the actual actuator which creates an alert is in the security room, isn't it? So the actuators and sensors will be in a different place, but how to interconnect these all these devices? Okay, you have to choose the proper gateways and you have to choose a proper data acquisition system. This is in the second layer. Okay, so, in the first layer, what are the research opportunities? So, as I mentioned, if you are an hardware designer or if you are an hardware programmer, okay, so you can come up with your own sensors, which is not available in the market, right? And you can also become a system programmer by designing and device drivers for these sensors and actuators. So this is a research opportunity in stage one. Coming to stage two, okay, so all those network research, concepts comes here. So the data acquisition. So how best you can capture the data? What are the data structures you need to store? Okay, you need to choose to store the data, like how to transfer the data. Okay, how to reduce the payload. Okay, so this kind of the research, this kind of algorithms you can come up with. How best you can analyze the data. How best you can capture the data and transfer it to the required devices. Okay, and coming to the edge. Now, edge IT. Edge is a layer in an IoT. Okay, so where the pre-processing of the data will be done. Now, for example, say you are just acquiring a data from the sensors. Okay, so you are not using any embedded system to process it here in the stage 2. What is the work of stage 2? It will take a data and send it to the cloud. Right now, before you send to the cloud, you need to do some pre-processing of the data, right? Because the devices, the sensors who is giving the data will maybe in a different format, right? Or when you are sending across the network, the data which you have captured might have changed to some other format, right? Or some redundant data may be there. Okay, so all this data pre-processing can be done at the edge layer, right? So then you can send the clean data or pre-processed data to the cloud. Now, for example, say you have to you have captured an image of a suspected in a public area, right? You have to find out is there any criminal background of that particular person. So what you are sending, the data acquisition is a camera here. You might have captured the image of that person, right? And the image as it is, you're sending to the cloud. Okay, so when you are capturing the image, it is not just that person is in the image, right? You have lots of background objects here. Okay, so now what the edge layer can do here, so it can remove all the background object. Okay, it can identify only that particular person as an object in the image and send only the image of a person to the cloud for further analysis. Okay, so like this you can make use of an edge layer. And finally we have a the cloud for deeper or more detailed analytics and for management of the devices and for security controls we'll be using the cloud. Okay, so this is a four stage architecture of IoT. Now let us take some case studies. You can use these case studies to simulate, okay, using any simulators. So now, IoT for energy management. Why? See, you can even do research based on the application. Okay, what I was talking four stage, the architecture here. You can do the research at the architecture level also, right? Means you design your own sensors, you design your own algorithms as a system programmer, or you can build a good GUI. Okay, come up with a good UI concept or UX concept, okay, to access these components. So at the architecture level also you can do the research. Or another way is to attach the IoT concept to an application. Right now, for example, you need an IoT for energy management. Right, you have a set of say devices which is connected here. So, for example, the home, the power grid is connected, a home appliance is connected, right, or few lights are connected. So the entire city, whatever the energy network is there, is connected, interconnected via cloud service or via internet. Right now, in this for this application, what are the open challenges? Okay, so you can identify the open challenges based on the application, and you can coin your research statement. So then coming to an IoT for biometrics, right? So now what is happening in the biometrics? Say you have a fingerprinting system, so it will scan the fingerprint, okay, and it perform future extraction of that, because you need to map, right? Already you already have some templates or some fingerprints stored. Now you're scanning the new fingerprint, right? So it should be sent on to the cloud for verification whether any of the patterns saved is matching with the fingerprint which is given as an input. Okay. So if there is a matching, then it will give you the result which you have defined. Right. So here also you can bring in an IoT. Here your biometric system is acting like a sensor. Okay. So which is capturing the pattern of the fingerprints. Okay. It is acting like a sensor. Now the sense data is the pattern of your, say the image of your fingerprint, right? So this data is sent to the cloud. Now, how are you connecting your biometric system to the cloud? So you may have to use an communication technology here, right? It may be on Wi-Fi, or it may be through internet, or it may be through Bluetooth. So here, which comes here IoT, right? So on the cloud, you say pre-process this image which you have scanned, and already there will be a database whose pre-scanned fingerprints are stored. Okay, so now you have to compare input with those fingerprint pattern which is stored, and you need a decision making algorithm here to decide if fingerprint is matching, what you need to do, right? So all this logic is implemented on the cloud, right? So this is how IoT for biometric works. And coming to IoT for security camera and door unlocking system. So now in this case, say you have attached a camera to the door. Okay, so now based on, suppose you have already pre-scanned and you have kept the face image of a say family members, right? So whenever a family member come in front of the door, the face image will be scanned, and if it is matching with the database, so the door will be open. So door will be unlocked. Okay. So the in this case, how IoT work. So you can check if the image of a person is present. Okay. The first step is capture the image. The camera attached to the door is capturing the image. It is just like, when somebody comes and ring the bell of the door. What do? You just see in the with the security sensor, or you see in the display who has come, right? So if you feel your identity, the person who is standing next to the door is a known person, then you open the door, right? Just like how human is analyzing whether to open a door or not, your door is doing on itself, right? So this is how you are making a things as smarter and capable of making a decisions. Then coming to the smart home, yesterday I was demonstrating how the smart home or the appliances can be interconnected, right? How they can be made as an independent devices. Then coming to the smart irrigation system. So yesterday there was a question by one of the participants. So how IoT can be used in agriculture, right? So you can use drones for sea field monitoring. Okay. So now you attach a drone camera, you capture the image, and using image processing, you can identify whether the crop is in a right direction or weeds are there. Okay, so what percentage of weeds is there? Okay, so where you need to improve the field activity, this kind of monitoring you can do, okay, using the drones. Now where is the IoT here? So the drone captures the image and drone is connected to the remote server via internet. Okay, so here comes an IoT concept. And or you can use a automated machines for routine operation, just like you have seen a remote control car used by the kids, right? So how they will be playing or moving the car using the remote control, same way you can use these machines. Okay, so sitting at one particular place, okay, you can use these machines all around the field. Then soil monitoring sensor. So yesterday I was giving you an example how the water monitoring can be done. Okay, so the you sense the moisture content of the soil, right? For a particular crop, if you feel the moisture content is less, then alert the farmer to water the field, right? So then water management, you can use IoT for water management. It is just a very few areas I've listed here. Okay, so if you go and do the field study for agriculture application, you will get n number of open issues and problems for doing your research. Okay, now coming to a smart irrigation system. So, say here, this is for again water monitoring. So we have you have used an Arduino board along with the sensors. Okay, so this is a soil moisture sensor. So along with the sensor, you have connected a sensor to the Arduino board. Why you need Arduino board here? The most of the sensor is on single application. Means it will sense the data and display it in the display board within a device itself. The soil sensors themselves, they can't communicate. Okay, so to make them to communicate, you need to attach an Arduino. Arduino is an onboard processor. It's a tiny processor, onboard processor. You can attach a Wi-Fi module onto the Arduino board. Right now, you're connecting a sensor to the Arduino board, Wi-Fi module to the Arduino board, right? Whatever data sensed by the sensor can be communicated to wherever you want. So that way you're making an soil moisture sensor which is capable of communicating, right? So here so you're connecting these sensors, or you're connecting this Arduino to the actuators, right? Now the sensor will sense the moisture. If there is a lack of moisture, there are two things you can do. One is create an alert to the farmer, or you go for a device which can automatically switch on or switch off the water pump, right? So here you can make use of an IoT. Now, coming to IoT in healthcare, okay. So here we have an haptics means you can use an the remote operation modules here. Means the patient will be in a different location and doctor will be in a different location, right? So they can control the equipments remotely. They can even perform the operation. They can even give the medications. They can monitor the patients, right? Now, for example, they'll ask you to wear a particular device which monitors your the regular, the blood level or sugar level, and it will be sending to the doctor. So, doctor can remotely see the condition and guide you remotely, right? So, this kind of healthcare system you can develop. Okay, so all these case studies can be a research topic, right? So one way is to do at the architecture level, which is a system programmer level. Okay, so other way, attach your IoT concept to any of the application, and then you can build a IoT system for that particular application. So that is also a research topic. So IoT in transportation, so you can connect different transportation or different vehicles, okay, for monitoring, for accident detection system, or even for traffic, monitoring. You can use IoT. Okay, so this tree will give you an overall devices and technologies you can use in a IoT. See, basically, what we need an hardware, right? Connected to a specific platform. Okay, so hardware which is connected to a specific platform. Now, when it comes to hardware, you can go for an the individual hardwares like sensors, actuators, switches, okay, relay or LED. Like this, you can use tiny individual hardware component, or you can go for a specific IoT devices. There are already the devices in which the processing unit and the sensors which is already embedded, okay, and you will get as a one single unit device. Okay, so they are IoT device. So in this you can use an embedded system. So for example, your Arduino, Galileo, Raspberry Pi, you can use this board, right, along with the wearable. Okay, or you can use a readily available wearable IoT devices, right? So if you want to customize your IoT device for a specific application, then you can combine accessories and embedded system. Okay, so like for example, in the smart irrigation, so you are using a moisture sensor, right? So you're using a moisture sensor, and then you're connecting it to the Arduino board, because that's a customized application. You don't have a ready IoT device to do the task, right? So that's why what you are doing, you are customizing your application. Okay, so or you can use say wearable devices like Android Wear or Fitbit, where already the processing or the IoT module is inbuilt in that. Okay, so depending on again on your requirements, you have to choose a specific hardware in your IoT project or an application. What I mean to say, you don't have to develop, the IoT system from the scratch. You don't have to start from ABCD. So there are already devices available. You can look at how to integrate them using an IoT platform. This can also be one of the IoT project. You don't have to end up with designing own algorithm. It's not necessary, right? So to start with, use a existing IoT device and integrate them using a known IoT platform. Then slowly you will come to know what are the open issues there, and then you can pin down to a specific problem statement and work on that. Now coming to the Babywise simulator. Here there are two things. One is the IoT platform and the simulator. Yesterday I was discussing the difference, right? So what is IoT platform? So So it's a platform which has a group of modules which can receive the data, communicate the data, which can process the data, which can make a decision, right? Which helps in monitoring, which helps in deployment, which helps in configuring. It can do everything using an IoT platform, right? So whether you are using an hardware as an IoT device or software as an IoT module, you require an IoT platform to interconnect all these devices, right? It's a must. Now coming to the simulator, what is simulator? See, sometimes what happens when we come up with the new ideas, we are not sure about our design, right? We coin the block diagram, but we are not sure about how this idea is going to work. Now, then how do you test it? Do you test it with the actual hardware? No, we can't do that because some of the hardware are costly, right? So you can't play with the hardwares like that. Then what is the solution? You need a virtual environment, okay, wherein you can easily simulate or wherein you can easily design your ideas. Now, in this kind of pandemic situation, where everywhere the shops are closed, you may not be able to access to a specific hardware, right? So then you is it that you have to stop your ideas and your implementation? You don't have to do that. You can go for a simulator which will give you an virtual environment. Okay, so here the modules are available which can act like a sensor, or you can design or you can make a module to work like a sensor which you want. Okay, so it will overall it will create an virtual environment in which you can design your IoT based ideas. Okay, so that's a whole concept of simulator, and this simulator in turn connects to the IoT platform. Okay, now coming to the Babywise simulator. So this Device simulator, the overall, has a very simple architecture. It has a publisher and it has a IoT platform and it has a subscriber. Okay, so three things. Now, what is a publisher? So, the publisher is the one who publishes the data. Okay, so now when the publisher is publishing the data, now the IoT platform will capture the data, right? Now the subscriber has subscribed to the same particular topic. Now, for example, your publisher is a temperature sensor. Okay, now the what data temperature sensor publish? It will sense the temperature of a room or a place where you have deployed it, and it will publish that value, right? Now your temperature sensor is a publisher. Okay, now we need a subscriber. Now subscriber may be your mobile phone, okay, where you are receiving the temperature value. Now the subscriber has to subscribe to that particular topic. Now what is the topic? Topic is the temperature level, right? The temperature level. Now publisher is publishing a topic temperature level, and the subscriber has subscribed to that particular topic. Now the subscriber will receive a message whenever publisher is publishing it. Okay, so means that whenever the sensor is publishing the temperature data, if you have a device which is subscribed to this topic, that temperature value will be received by the subscriber. Okay, and also even IoT platform can subscribe to the or publish a data to the subscriber. Okay, so here the UI simulator makes use of a simple publisher subscriber MQTT model. Okay, so we see what is MQTT model. It's a message queuing telemetry transport model. So where the device communicate through the messages, right? You're not using any great data structure here. You're using a simple message. In a message, you are embedding the data which you want to send, and you are sending the data to the devices connected, right? So here a device which is an MQTT client, a publisher, it will publish a data. Right now, it is publishing a message on. Okay, so the topic is home/office/LAN. Means you are using this network to switch on or switch off the lamp or the light. Okay, now the device, okay, a specific device will tell whether you have to switch on or switch off the light. Okay, now what happens here? The device will publish. Suppose if it is publishing a message equals to on, okay, and we have a subscriber who has subscribed to the same topic, right? Now this subscriber will receive a message on and it performs the action, right? So in this example, the publisher can be a phone, okay? The publisher can be a phone, and the subscriber can be a switch, okay? Switch which is capable of communicating. Now what happens? Now the mobile is publishing a message on, okay, because the switch is subscribed to this topic, the switch has received the message on and it is switching on the light, right? So like this you can use an MQTT model and you can transfer the the commands and the data as a message. The same architecture is used in Babywise simulator. It means it has made an interface and the communication very simple. Okay, now, why you have to go for this Babywise simulator? It will, you can perform a functional testing, you can perform a load testing. Suppose you want to increase the number of sensors and see how your architecture work, okay, how the message is transferred, how much time it is taking, right? What is the delay? So, this kind of testing you can perform. Or for the beginners, this is a very good virtual platform to learn the very basic concepts of IoT and how the sensor works, how the subscriber works, and how the MQTT, how you are performing a device management. Okay, so all these concepts you can easily understand through this particular simulator. So, this is the overall components of Babywise say simulator. So we have, as I said, you can publish a data, you can subscribe for a specific topic, right? So you can create your own virtual IoT device. Any sensors you want, you can simulate here. So virtual IoT device you can create, and we have a managerial application. So not only for Babywise platform, you can connect this simulator to any other platform. You want to connect to Azure platform, you can do that. You want to connect to Salesforce platform, you can connect via this Babywise simulator. And we have a manager dashboard, right? If you have to talk to the sensors, or if you have to control the sensors or publish a message to the sensors or any devices connected, you can easily do because they provide a very nice GUI. Okay, so you can even create a report on the sensor data, right, using the manager dashboard, right? And we have a CSV file. So I will explain when I'm demonstrating how to create an events about this CSV file. Suppose you want to say deploy 500 sensors. You want to simulate an IoT network with 500 sensors. You don't have to create 500 sensors manually. All you have to do is just get the values in a CSV file, upload, and it will automatically create an 500 the virtual sensors in the simulator. So that's where we are using an CSV. And coming to the message, okay, the data structures this simulator is using for messages either in the form of a text or in the form of a JSON. Okay, then for communication, it is making use of REST API. What is the advantage? It's a faster IoT simulation. As I said, suppose say you want to create 500 different sensors in one go. You can do that. You can go for a bulk creation of virtual IoT devices, or you have say one particular sensor. For example, you need around 100 temperature sensor, only temperature sensor. That also you can create in one go using the templates. You can even connect your simulator to the backend, that is to the database, right? So then you can easily configure the simulator. You don't have to write too much of code. There is no, the programming, with very less programming. you can simulate here just with the GUI components, drag and drop components, and the configuration is made easier in this particular simulator. And we have a very reliable MQTT support. Okay, so which will ensure and quality of service at each level. So it has a clean session also. I'll tell you what is clean session when I will be taking the hands-on session. Okay, so next we'll see how to download and install and configure the Babywise simulator. Before I go to this, if you have any questions.
Yes, ma'am, I'll send it to you.
Okay, the first question, can you say how ML and IoT are related? See, if you remember the ecosystem I discussed, okay, so in the ecosystem, we have the smart grid, smart light, the smart devices, right? So here comes an IoT application. So it is not just you create any physical device. You need to make them smart. You need to make these devices autonomous. Autonomous means it should be able to take a decision on their own. Okay, so definitely, how do you incorporate intelligence to the physical device, to the hardware? So you need to implement an algorithms here. There comes your machine learning. Okay, see, machine learning is not just making a computer intelligent, right? So it is any hardware you take, okay, incorporating an artificial intelligence to that. Okay, so there comes in machine learning. Is it necessary to learn cloud computing for IoT? If so, how long will take? See, it depends on the problem you're considering. Okay, so if you are and the how much percentage of cloud you are using in your project, right? So to start with, you don't have to learn more about the cloud computing because you are using a very specific services, right? So you don't have to go on the research concepts of cloud computing. That is not necessary. So first you decide at which layer you have to work in IoT, and then you can learn the concepts based on that. How can IoT applications have security? Yeah, this is a challenge, as I mentioned yesterday, right? You cannot implement a full-fledged security because if you lock a feature, then the IoT, will not work. The concept of IoT is removed there, right? So it is very challenging that you have to keep a device open for all the data by ensuring the security. So that's a challenge. Whether sensors used in Adobe networking is using IoT. See, you can use, see that wireless sensor nodes. Yes, you can use sensors used in Adobe network in IoT also. Okay, provided if it can, the sense the data and, send it to the remote machine. See, the sensors will not do any business decision. Means sensors will not do any data processing. Clear? Sensor, the work of sensor is just to sense the data and it has to communicate, right? So that's all we need from the sensors in the IoT, right? So some sensors, they cannot communicate because they don't have the communication module in them. So there you bring in the embedded system, right? So what sensors you are using in Adobe networking can be used in the IoT. So what is the role of IoT in healthcare sector? So you can go for a patient monitoring system, you can go for a remote operation. Okay, so you can go for an health monitoring system, you can create an health alerts, you can even you can use IoT in the pharmaceutical field. Okay, so while implementing IoT security research, can we consider in terms of use case? Yes, you can consider for a specific use case, you can go for a security algorithm. If you take in the healthcare system, right? You are remotely monitoring the patient data, isn't it? So the patient data should follow the privacy concerns, isn't it? You cannot leak the patient data to the public, right? So there you can go for a security measures and you can do research over there. Like this, you will get many problems. Does NS3 support MQTT? Yes, NS3 is having an MQTT module, or you can integrate NS3 with any other existing external MQTT modules. You can integrate it. Why JSON is used more nowadays? See, JSON it provides you the data structure, a very simple data structure and the nested data structure where the complex data can be easily stored. Okay, so that's why you are going for the JSON, and also the memory management. Okay, so message is a kind of static. Okay, whereas if you go for a JSON data structure, the message is built on the fly, right? The data is built on the fly. So that's another advantage of going for JSON. Okay, so any more questions? So why can't we prevent accidents using IoT? Yes, we can. That is what one of the applications we are working on, right? But all these devices or system has their own advantages and disadvantages. Okay, because the communication, everything matters, and it's quite complex because we are using too many technologies, right? For if you take one single application, we'll be using too many technologies, and integrating all this technology is not a easy task. Yeah.
Thank you, ma'am. And these were the questions there. We can continue the session.
Okay. Thank you. So I'll be now demonstrating how to download and install Babywise simulator. You can also do it parallelly.
Ma'am, it's not audible, ma'am.
I'm sorry. Yeah, I am muted. Screen is visible.
Yeah, it is visible, ma'am.
Okay. Yeah. So I'll just explain once again. Okay, you go to babywise.com, click on all downloads. Okay, and you have say many products here. You can also get a separate MQTT router here. or you can go for a TCP suite also. You're asking a question like NS3, does it support IoT? Okay, if all you need is an MQTT and you need to connect to a suitable communication, right? So if it is not available in the existing any simulator, see if you can download this MQTT route separately and integrate with your available simulator. That can also be done. So now I'll go. I need an IoT simulator here. So depending on the operating system you're going to use, right? So you have to choose. If you are using 32-bit operating system, choose that. Or if you are using Linux, you can choose that. So I'm using 64-bit operating system. So I will choose that. So now enter the details here. Operating system, click on the download. Okay, so to see whether the simulator is compatible with your system or not, you can look at the requirements. So this is a minimum requirements you need for IoT simulator. Okay, now this I'm opening this exe which is downloaded to install it. So take care, like you may come up with the firewall settings. Okay, so if you are not able to run this exe, right click on the exe and give option as run as administrator. Okay, so you may have to give some security permission for installation. Now accept the terms and conditions. So I'm installing this simulator in a C drive, Babywise folder. Okay, you need to remember this because there is no icon generated on the desktop. Okay, so after installation, if you try to find any icon on the desktop, it is not available. So they don't provide an icon support. Now what you have to do is you have to go to this folder and then you have to run the simulator. Okay, so remember whatever path you have given here. So I've given in a C drive Babywise folder. So click on install. So you may come up with the firewall settings. Okay, so just disable the firewall and then run the installation or run as an administrator. Right, now click on finish. Okay, so now what I'll do is I'll okay, 1 second, I'll share. Yeah, so now I've installed it. So what I do is I'll go to the say C drive, go to C drive. So I have a Babywise folder here. Okay, IoT simulator. So these are the files which is installed. Okay, go to bin. You have run simulator file. So click this run simulator file. Okay, so it will open your default browser. IoT simulator, it will open in a default browser. What I do is I'll just take it to the Google you can continue with the Internet Explorer if you are comfortable with that, or you can shift to any browser you want. Okay, just by copying the URL. So this is a homepage of the IoT simulator. Okay, so I just repeat a step. I go to the installation folder and go to the bin folder. Click on the run simulator. It will automatically up the simulator and open the uh, say browser. Okay, open the simulator in the browser. Right now here, so already some demo network is available. Okay, so that demo network will be displayed. Now I need a new simulator. Okay, new network. I have to design a new network. Now go to new network option. So here you can give a name of a network. So I'll give demo IoT network. So give a description. Click on create. Now this is a simulator setting. This is a broker setting. This is for MQTT broker. Okay, so you have to do some configuration. And remember, once you do this configuration, you cannot change later. Okay, so you should be careful when you are doing the simulator settings. Now there are two settings. One is the basic broker details. Other one is the advanced settings. Now coming to the broker details. So here, see, if you have to connect to the any IoT platform, so you want to connect to the Azure platform or AWS platform, okay, so you can connect. So you can choose here. Now I want to connect to the Babywise IoT platform, so I am choosing that. So you have an broker IP address here, device manager babywise.com. I will tell you what is the use of this link in the tomorrow's session. Okay, so if you go to this link, you will get a device manager. Okay, so you can do lot of configuration work or monitoring work using this particular device manager, right? So now, if you want a security, SSL layer enabled, then you can click on enable. The corresponding port will be chosen. Okay, so the default port for SSL will be 8883. So if you are enabling the SSL or TLS security layer, then you have to provide a root certificate. Okay, so where the root certificate will be, if you go to, okay, so Babywise the installation folder. So you have a folder called as certificate. Click on that. You have a root folder. So select this certificate and upload. Okay, so this is when you are enabling the TLS SSL layer. Okay, otherwise you don't have to go for a root certificate. Now I don't want a SSL layer, so I'm disabling it, and the corresponding default broker port is 1883. Okay, at this port, so the publisher data will be received and it will be communicated. Okay, so coming to the clean session. Now what is clean session? Now the publisher is connected, will be connected to this broker, right? So if you remember, we have a publisher, we have an IoT platform, and we had a the subscriber, right? Now on the IoT platform, we will have a broker, MQTT broker, right? Now the client publisher will be sending a data to this broker, isn't it? So when you disconnect the publisher, okay, so if you enable clean session, when you disconnect the publisher, the broker will remove all the data which is received if you enable the clean session. If you disable the clean session, then all the history data will be available with the broker, okay, for that particular publisher or for in that particular network, right? If you want to remember the history data which the publisher has published or subscriber has received, okay, all the activity, then give a clean session as 0. Or if you want to reset a flag, or if you want to delete the older data, you can give a clean session as 1. You can enable it. Okay, so now I'm giving clean session as 0 here. Now coming to the advanced, suppose if you are using multiple, say publishers, say if you are using 50 publishers, so instead of giving a device ID, you can give an IP address to them. Okay, so for if you all 50 individual devices, defining IP address is very difficult, right? Now in that case, you enable the IP address, you give a range of say IP address here. So within this range, the IP address will be assigned to the publisher devices or client devices. Okay, so now I'm not using too many client devices here, so I'm disabling the IP address. Now coming to random start or stop. So here, if you enable this random start or stop, and if you give uptime as 50, so when the device uptime reaches 50, okay, it will automatically enable and it will disable on its own. So here I'm choosing disabled. Now coming to the Python interceptor. So if I enable this Python interceptor, okay, so here we automatically for this particular configuration, a default a Python file will be created, okay, and where this will be stored. If you go to the installation folder, okay, go to extension. So here you have a default interceptor. This is a Python file, okay. Now, if you open this file, see, already the skeleton code is generated. Here, function intercept client topic name data, right? You can write your own code, your own Python code telling what to do with that particular topic and the data, right? So even you can, integrate a Python code here. Now somebody is asking how to integrate machine learning algorithms, right? So here you can bring in the machine learning code. Okay, you can for a particular client. Okay, for a specific topic, if you want to incorporate a machine learning concept here you can embed code for that, Python code for that. Okay, so this is about the broker setting. I'm disabling because I'm going for a very simple, network. So check all the details once, because once you say this, you will not be able to change the settings here. Okay. So now click yes. So now the configuration is saved. We created a network, new network, and we did the broker configurations or simulator settings, right? So these two things. Now we have to add the devices, right? Now before you do these things, you should do a proper homework on what devices you need in a network, okay, what each devices will be publishing the data, what kind of data, what is the format of data this has to publish, right, what should be the role of subscriber. All this homework you have to do and then start the simulation. Okay, now I'll be say taking say two devices here, that is two sensors as a publisher. Okay, so to add a blank device you can select add blank device here, option here. Now write a device name. So device name is a temperature sensor. So device id you can give, it gives say p1. Yeah, p1. So write a description, this measures the temperature. Okay, so click on save. Right, now say I want to add one more device to this. Say I want to add proximity sensor to this. You can see on the top right corner you have a plus mark. Okay, so click on that, select blank device. Okay, so select blank device. So now you give a device name. Say I want proximity sensor. Okay. So I'll give it as PS1 is a device ID. This detects nearby objects or metals. Okay, so now I have added two sensors to this, right? So next, I need one subscriber for this. Okay, so I will add a subscriber device. So again, click on plus blank device. I'll write it as subscriber. The one who receives the publisher data. Here, proximity sensor and temperature sensor will act like a publisher. Okay, because they sense the data and publish it to the network, right? So we need a device who captures these data. So for that, we are going for the subscriber. So I'll write subscriber device ID as SUV1. So write the description. This is the subscriber. Okay, click on save. So now I have three devices. I've created a three devices here, right? Now we have to take next step is to create an event. Now what is an event? Now suppose a temperature sensor senses the data, right? This capturing the data is an event. Is the data what it should do, right? Whether it should keep a data with it, or whether it should send it to the remote machine, or whether it can create an alert, or whether it will just display, or whether it will blink the light. Okay, so the event is capturing the data here, right? So you have to tell when this device has to perform the event and what event it has to perform. Okay, so if you take an actual device, actual temperature sensor, right? When the say maybe for every 5 seconds, you are asking the sensor to sense the temperature, right? So every 5 seconds, it is performing the event. What is that event? It is capturing the temperature. Is an event, right? Now same thing you have to simulate here for the temperature sensor. So for that, you are creating the event. Okay, so now how to create an event? Now I have to create a say uh, event for a temperature sensor. Select that, select the temperature sensor. Okay, now you click on this plus mark. We have a list of events, right? We have different events supported here. So for a device, okay, we have say total 7 events we can design. Okay, now I'll be explaining these each of these events. Now say you have event on connect. Okay, so this event on connect is performed whenever the device is connected to the broker or connected to the network. So for example, when the temperature sensor is connected to the network, it will perform the event which you have defined. Okay, then on disconnect, when the temperature sensor is disconnected from the network, then it will publish a message. It will create an event. Okay, so when the temperature sensors connects to the network, it will publish one message, right? So publishing that message is an event. When it disconnects, it will publish one message, right? Then specific time, you can ask the device to publish a message in a specific time. Okay, so now, for example, if you say at 11:05 a.m., the temperature sensor will publish a message when this particular time is equal to the system time. Okay. So next event is say instant. So if you want to publish a message manually, then you can go for an instant event. Okay, so when you create this event, there will be one action button created. So if you click on the action button, then the device or a sensor will publish the topic or publish the data. So this is instant event. So next is specific duration. Now, for example, you can give a specific time duration. So here you've selected 7:30 a.m. to say 12:45 a.m. So within this duration, you can ask a device to publish data, say every 10 second once, or every 15 seconds, or every 5 seconds. So it will automatically start publishing the data. Okay, so you can publish a data within a specific time duration or at a specific time, or you can manually also publish. When you click on a button, it will publish the data, or you can make a device to publish a data for 24 hours for a whole day. So you can give an interval. Say for an entire day, it should publish a data, say for every 5 seconds, or for 10 seconds or 20 seconds, like that. Okay, So next we have from CSV. Suppose say I want to create for a temperature sensor itself, one sensor itself. I want to create a multiple events, right? Say I want to create around some 60 or 70 events for one device. Then instead of creating one by one, what you can do is you can upload. Okay, there is a specific format of CSV where you have to specify what is a topic name, what is a QS parameter, okay, what is the number of events, right? So you define all these things in a CSV file and you upload it here. So automatically the events will be generated. Means for a particular sensor, if you have to create a multiple events, then you can go for a CSV. Okay, then we have a behavior event. So this behavior event, for example, say when the temperature sensor gives you a value 50, means if the room temperature is 50, you have to publish a message, right? So in that case you can go for a behavior event, and you can create a subscribe. Now we have a subscriber. If you want to make a subscriber to subscribe a topic which is published by the temperature sensor, right? So then you can go for a subscribe for command event. Okay, so these two events, behavior and subscribe to command, will be using an event for the subscriber. The remaining events will be using for the sensors or the for the publisher. Okay, so this is about the events supported in IoT simulator. Now let us create one event. So I'll create one simple on connect event to the temperature sensor. Okay, so here topic is temperature level. See, it's a standard. We write a topic name separated by the slash. So it means that I want to sense the room in a room temperature. What is the current level of the temperature? Okay. So I'm writing it as room slash temperature slash level. Okay. Now QS, say at most once you have to check for the QS, the quality of service for this particular event. So you can say check at least twice or check at least once. You can choose this option. Okay, and after publishing the data, if you have to retain the data, then you can select set retain flag, or you can give a clear retain flag. Right now, here you can select whether this particular topic or a message which this sensor is publishing should be in a simple text format or should be in a JSON format. Okay, so I'll show how to create a message using JSON format. Now I'll select it as a text format. Okay, now text format. Now here you can give a specific value. Now to give a value for this, you should know what is the actual value sensed by the temperature sensor, isn't it? So you should know the hardware configuration. For that, what you can do, you can see any specification of say temperature sensor or proximity sensor or sensor which you want to say simulate here. Means you should know what is the range of data. See here, if you go to the specification of a sensor, it can give you or sense a data from 0 to 100 degrees centigrade, right? So and it 0 to 100, so it can the data or the value published by the sensor can range from 0 to 100. Okay, so this is what the homework you need to do. You identify the sensors, then you have to you should know what type of data it can sense, what is the value it can sense, what is the format of the data it can send, right? So all this homework you have to do before doing the simulation. Now for temperature sensor, the value ranges from 0 to 100. Okay, now what I do, if I choose a constant, now suppose I give 10 here. So every time when it publishes, it will publish on 10, value 10 only. That is a constant value, right? Now, if I go to the system variable, suppose if I have to say send the client uptime, okay, then create a client uptime. When the sensor when this temperature sensor is connected, when it is up, that particular time will be published. Okay, or if we have to say publish the system time, then select the current time, or if it has to publish the client id, then you can select the client id. Okay, so coming to the next, random. So if you have if the value is a random value, or randomly if it has to publish on or off, then you can choose a random and give a messages on or off. Means randomly, without any sequence, it will just keep publishing value on and off. Okay, but now for our temperature sensor we need a range of value, that is from 100 0 to 100. So what I choose the variant as a range. Okay, so the range is from 0 to 100. So you should well know about your sensor. Okay, that's a conclusion here. You should know what data, what is the format of data, what values, the range of values it can send. Okay, so in yesterday there was a question: can we simulate a physical sensors which is not available? Yes, answer is yes. So you can simulate any sensor even though it is not available in the market, but you know the sensor specification. Still, you can simulate it using this simulator. Okay, so click on save. Right, now here you can see the event is generated. Okay, so event is generated when the when this topic will be published, when it is started. Means when this temperature sensor is connected to the broker, the topic will be published. Okay, so next, coming to the proximity sensor. Now for this, see, for a particular sensor you can create as many events you want. Okay, now when the sensor is connected, you want to perform one event, create it. When during disconnect, say if it has to publish a message, you can create one more event here on disconnect, like for example like this on disconnect. Okay, so you can write disconnection message is a topic. Disconnection message is a topic. Okay, it can be as a text. Okay, so constant, you choose a constant. So you can write I'm disconnected or disconnected, something, some message, right? So you can write disconnected. Means when the temperature sensor is will disconnect from the broker, it will publish this particular message. So like this, you can create as many events you want. Okay, depending on the condition, right? So on connect, say what I do is I'll modify here on connect. So I'll write connect message. Okay, so I'll take a constant here. I'll write a message is connected. Okay, means when temperature sensor connects to the broker, it will publish a message as connected. Right? Have written for on disconnect. I have written for on start. Now what I do for the whole day? Say I want to sense the temperature. Right? Every say 10 seconds. Right? So here I will write a room temperature. I'm trying to sense a room temperature for every five say 10 seconds here. Room temperature slash level. Okay, so here I need a range of values. So the value it can publish can be 0 to 100. See, I have for temperature sensor alone, I have created three events. I have told what it has to do when it is connecting to the network, when it is disconnecting from the network, or when it is up during the entire day, right? So different events you can generate for a particular device. Okay. Now coming to the proximity sensors, let us define an events for this. Now before that I should know the specification, what data a proximity sensor will give, right? So I'll search for specification of proximity sensor. Now say here, see you have a different values, right, for different conditions. So go through this. properly what value you need. Okay, so for sensing distance 2 mm, right, means if the object is nearing, the distance between the sensor and the object, right, is 2 mm or 4 mm, we have a different values. Okay, it can give you the different values, right? So go through these specification thoroughly, and as per that, you have to define there. Okay, that way you can simulate it to the actual values of the sensor. Okay, otherwise you can even give a random value. Okay, but if you have to do the simulation for the actual value, then you need to do all this homework. Okay, so now I'll take an value from 0 to 20. Okay, for a specific metal. Now create an event. I'll write connect event. So it's a connection message for proximity. Proximity. Okay, I'll write proxy, connection message proxy. So I'll write constant message proximity connected. Okay, so when it connects, it publishes a message as proximity connected. So I'm using here a simple text message. Okay, then same way for while disconnected, you can write disconnection, disconnect message proxy. So constant proximity disconnected. Okay, now click on save. Right now, say for I'll create for a specific time. Okay, or let us create for a specific duration, right? So 7:30 a.m. to 12:45 a.m. You can change this if you want. You can change this to say 10 p.m. 10. So now the topic is proximity level. Proximity level. Okay, means say if somebody is bringing a metallic object nearby, it should create an alert. So I will write proximity of metal. So proximity of metal level, a specific metal. So here the value ranges from metal to metal. So you have to look into the specification of the sensor. Okay, so that way you can identify whether it is an hazardous metal, then the alert has to be created. So I'll go for an say linear value. Okay, so it will give you a linear range of value, or even you can go for the constant, or you can go for the range. Okay, so I'll take 0 to 20 ppm, right? So value here. So this is for a specific duration. Now, let me create one more event using JSON construct here. Say I'll use whole day. See, every 20 seconds I will choose. So here also proximity metal level 1. I'll give it as level 1 just to differentiate between the topic. Okay, so here I'm going for the JSON. Now JSON has a different objects. Okay, so say array objects. You can define a message as an array object, or you can define a message as an object or a constant or system variables. So it means that see array can be embedded in a JSON object. Okay, or you have a specific object or construct that you can embed in the JSON object, or a constant value can be embedded in the JSON object, or even system variables. Any of these variables can be embedded in the JSON object, or you want to create a range can be embedded in the JSON object. Okay, now what I'll do, I'll take a say client ID. Okay, so proxy ID. I will add. Okay. So now I will add one more key, proxy ID. So I will write proxy value here. Proxy value. So proxy value, I'm taking it as a range 0 to 20. Okay, 0 to 20. Now add. Okay, so like this. So here, so the JSON contains two values here. Okay, one is the client ID and the value. Okay, so if you see in the text, either I could publish client ID as a separate and the range of value as a separate. Right now, what happens? A single message holds both client ID and the value here. Suppose if you have a complex message to publish, then go for the JSON construct. Okay, so now this complete construct will be published as a message, single message. Okay, so I'll click on save. Right. So this is how you create an events for the specific device. Okay. Now I'll create an event for the subscriber. So for subscriber, I will subscribe. I'll use a subscribe. Before that, I should know the topic for which I want to subscribe. Okay. See, you don't have to subscribe for all the events. The subscriber, whether subscriber is interested to know the temperature sensor is connected or disconnected. No, the broker wants to know, not the subscriber. Right. The subscriber only wants the temperature, room temperature. Right. So I am taking a topic. I'm making a subscriber to subscribe only to this particular topic, that is room temperature level. Okay, so I need a topic name here, that's why I'm copying it. Go to the subscribe to command, write the topic here. Okay, so when the subscriber is on, it should subscribe to the topic room temperature level. So that way the subscriber can receive a message about room temperature from the sensor through broker. Okay, now I'm subscribing to this topic. Now coming to proximity, I have four values here. So say maybe the subscriber is interested to get a value at a specific time. So I'm choosing that particular topic. Okay, which it gives a value to the value in a specific duration. So I'm subscribing subscriber to that particular topic. Now see how many events are there? 1, 2, 3 events, and proximity has 4 events. Total there are 7 events, but I'm subscribing subscriber only to the 2 events out of 7 events. Okay, the remaining 5 events, the sensor will keep publishing it to the broker, may not be sending to the subscriber. Right. So now this is how we create an okay events to the device. Okay, so the next step is we have not yet connected these devices to the broker. Okay, we have just done the settings of the broker, but we have to connect, say temperature sensor should be connected to the broker, proximity should be connected to the broker, subscriber should be connected to the broker, then only all these three can communicate with each other. Right, so here broker is nothing but your IoT platform. Right, now how to connect these devices to the broker or IoT platform, and how to make them to communicate with each other, and how to control these devices through the device manager, we will be discussing in the tomorrow's session. Okay, so that's all for today. If you have any question, you can ask.
Yes, ma'am, I'll send it to you.
Yes, please. Can I use IoT irrigation to control motor? Yes, you can use even a motor speed can be controlled using an IoT device. Yes, you can do that. So, what is the working language of IoT device? It depends. Okay, it depends. Like most of the, it depends on the technology you're using, right? So you can't say one or two language here. How can IoT be used in ship navigation? So you can say for this monitoring, or to get the location of the ship, or for showing the direction, or automatic controlling of a ship whenever there is an obstacle, or the aquatic animal detection, right? So these kind of problems you can work in a ship navigation. So, what points should we keep to develop our own sensor for research? First, find out why do you need that sensor, what data it has to sense, and where you have to deploy. Okay, so you need to answer these three questions if you have to develop your own sensors. How will the configuration be if numerous sensors are used and these sensors have a same function? Yes, we have an option called as a template. Okay, so that I'll be demonstrating tomorrow how to use how to create a sensors using template in the simulator. Can we create this IoT app and run using IoT simulator? Yes, you can do. You can create. All you need to do is a GUI, right? So you can create a GUI, app-based GUI, and then you can connect it to the simulator. Is there any online simulators apart from IoT simulator? There are many IoT simulators available. You can try with IBM Bluemix simulator also. So we have IoT 5 is an online. There are many cloud-based simulators are also available, which is open source.
Thank you, ma'am. I guess only these many questions were there in the chat box.
Okay. Thank you. We'll meet in tomorrow's session.
Thank you so much, ma'am. It was another interesting session. We are glad to be a part of your webinars, and it is very well seen in our chat box. It is flooded with compliments. Thank you for giving your time, and we'll meet tomorrow with your next session. Thank you, ma'am.
Thank you so much.
Thank you, ma'am.